Hello everyone. So this is part one of our exam one solutions that we are doing for extra credit. This will be broken up to a couple videos just to save time, so you're not sitting here watching a whole bunch of stuff. Let's get right into it. So to save time, question one, we're going to compute the integral of sine 7x to cosine 5x. So to save time, like I said, I wrote down the formula that you need to actually compute this, which is a product the sum of two angles formula. So we have sine A cosine B. This is our A. This is our B. We're going to have 1/2 sine A plus B plus sine A minus B. Without this formula, pretty much stuck. So from here, let's go ahead and just get started. So let's take our constant out, our 1/2, our integral, so sine 7x plus 5x plus sine 7x minus 5x dx. Cleaning it up a little bit, we're left with 12x sine, of course, plus sine of 2x dx. So from here, we can now take our integration. So from here, we have negative cosine 12x, but since we have that 12 in the middle, we have to divide this entire part by 12. Cannot forget about that. We have the same integration here, so minus cosine, but instead we have a 2x, so we're going to divide everything by 2. And then from here, we're just cleaning it up, so we're going to take our 1/2 negative cosine 12x over 24 minus cosine 2x over 4 plus our constant of integration. We cannot forget that, okay? So this is the answer to number 1. And then let us move down to part 2 of question 1. So, a spring has a natural length of 28 centimeters. If a 28 Newton force is required to keep it stretched to a length of 36 centimeters, how much work, W, is required to stretch it from 28 centimeters to 32 centimeters? And we are going to round our answer to 2 decimal places. Alright, so let's write down some key pieces of information here. So let's start off with our 28 newtons of force. So our force, 28 newtons, okay? I would also like to find our change in x, which is going to come from here because we're stretching. This will be our change in x. So change in x equals 32 centimeters minus 28 centimeters. Equals 4 centimeters. We're going to convert this into meters. And left is 0.04 meters. We're going to need this in a second. And we're also going to write down this equation, which is going to be Hooke's law. So k, force times our constant k times x. Well, we can write this as change in x. So we have our force, 28 equals a constant k for our change in x. I'm going to put it around brackets so there's no confusion. We want to get k by itself. I'm going to subtract 0.04 from both sides. So k is going to give us 28 over 0.04, which equals 700. This number we're going to need for our integration. Now, from here, we can actually go ahead and set up our integral. So we have our bounds. So we're going to take the integral from 0, because it's starting out of nothing and we're stretching it that distance. I'm going to move this a little bit. Our 700 is going to become our constant here, which would be k, and then we have x dx. So from here, we're going to take our 700, we're going to integrate it from 0 to 0.04, and we're going to have our x. We cannot forget our dx. So let's go ahead and integrate 700, 1/2 x squared, and we're going to take that from 0 to 0.04. The 0 is going to make a 0, so we don't have to worry about that. So 700 1/2 0.04 squared. It's going to leave us with 0.0008 minus our 0. So I'm just going to take that into it, times 700. And our work is going to be 0.56 joules. Okay. And that is the answer to part 2, question 1. Now, let's get to question 2. And after this, we're going to go ahead and stop. So, question 2. Compute the volume of the solid formed by revolving the region bounded by the graphs y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis. You may either use a shell, disk, or washer method. We need to sketch the region, find limits if necessary, find our height and radius of this specific shell, disk, or washer. In this situation, we're going to be using shell. We're going to set up the integral for said volume, and then we're going to solve for that area. So our first step, just so we can see it, is we're going to sketch our region. So first things first, we're going about the y-axis. So we're just going to make a little arrow, just to remind us which way we're going. Now, x squared plus 1, a normal x squared graph starts something like that, where we're going to go to 1. And we're going to go all the way. I'm going to make a point right here, and you'll see why in a second. Make a point right here, and we're going to stop. Y equals 0, x equals 0, and x equals 1. This is going to be our stopping point, our x equals 1. Okay. Since we are using shell method, our rectangle here has to be parallel to the rotation of the axis. Since we are rotating it about the y, it's going to be parallel to the y. And we're just going to fill this in just to illustrate. This is going to be our change in x. So yeah, just making sure I'm not forgetting anything here. Looks good. So this whole thing is going to be rotating that way, more or less. So from here, find our limits if need be. Well, we stopped at 1, right? So our limit's going to be from 0 to 1. So x equals 0, x equals 1. Now our radius for this, it's going to be our rectangle, which is going to be our x, and our height is actually going to be our function, so y equals x squared plus 1. Okay? So from here we can set up our integral. So we are dealing with shell method, so if it's about the y-axis, this is what the formula looks like. 2 pi, the integral from a to b, x, f of x, and I'll have this make sense in a moment. Our f of x is going to be our function, and our x is going to be our radius. So I'll set it up right down here, and then I will solve it next. So we're going to go from 0 to 1, x squared plus 1 dx, and then from here we'll solve. So we're going to throw our x right into our equation. So we have 2 pi 0 to 1 x cubed plus x dx. We can go ahead and do our integration. 1 over 4 x to the 4th plus 1/2 x squared, 0 to 1. Now we notice our 0 here is just going to give us 0, so we technically don't have to worry about it, but we're going to write it just to show it anyway. So 2 pi 1/4 1/2 squared 4 minus, and we'll just show 0. And then when we actually do the math out for this, we are going to be left with 3 pi over 2 units. And that'll be our answer to question 2. And this will be the end of part 1 of our video series. So thank you for watching.